B-21 Raider, the bomber that makes air defenses irrelevant. Imagine being the commander of an advanced air defense network on a completely dark night. Your radar screens are alive. Long-range surveillance arrays are sweeping hundreds of miles of sky. Tracking radars are searching for anything that might become a threat. Missile batteries are connected and waiting. Fighter aircraft are standing by. Every sensor, every data link, and every command station is operating exactly the way it was designed to operate. And yet something is wrong. Not because the system has failed. Not because someone has shut it down. Not because an electronic attack has blinded the network. The problem is much harder to solve. There is an aircraft somewhere inside the defended airspace. And your network cannot build a reliable picture of it. You may receive indications that something is present. You may know that something has entered the region. But knowing that something exists and being able to turn that knowledge into a weapons quality track are two completely different things. That distinction sits at the heart of the B-21 Raider. Because the objective behind America's newest stealth bomber was never simply to build another aircraft that could survive enemy defenses. The deeper objective was to change the question. Instead of asking, how can a bomber break through the world's most sophisticated air defense network? The B-21 asks something much more uncomfortable. What if the network never gets a useful opportunity to fight back? For decades, that question would have sounded almost impossible. But modern air combat has been moving toward it for generations, and to understand why the B-21 matters so much, we have to go back to the basic contest between aircraft and air defense, the wall in the sky. Modern air defense is not one radar sitting beside one missile launcher, it is an ecosystem. Far from the front line, large surveillance radars search enormous areas for incoming aircraft. Their job is not necessarily to identify every target with perfect precision. Their first responsibility is to provide warning. Something is approaching. Something is moving through this sector. Something needs attention. That information is then passed deeper into the network. Tracking radars attempt to refine the picture. Command centers combine information from multiple sensors. Missile batteries prepare launch solutions. Fighter aircraft can be directed toward the threat. The entire system functions like a giant nervous system. One component detects, another interprets, another tracks, another decides, and finally, a weapon attempts to destroy the target. This architecture is extremely powerful because it does not depend on a single sensor. If one radar misses something, another may detect it. If one sensor produces an uncertain track, several others can potentially contribute information. If a threat approaches from one direction, multiple weapons can be positioned to respond. Layer enough of these systems together, and you create something military planners call anti-access and area denial. The objective is simple. Make entering the defended region so dangerous that an attacker chooses not to enter at all. For decades, this has been one of the central problems facing American air power. And traditionally, the solution was brutal. You did not try to make the entire defense disappear. You attacked the defense itself. The old way through. Imagine an American strike package approaching a heavily defended region. The bombers are not simply flying toward their targets. They are part of a much larger operation. Electronic warfare aircraft may be working to interfere with enemy sensors. Other aircraft can perform suppression or destruction of enemy air defenses. Decoys can complicate the defender's picture. Fighters can protect the package. Tankers keep aircraft airborne long enough to complete the mission. Command and control aircraft coordinate the entire operation. And behind all of them is the actual strike force. This is what defeating an integrated air defense system traditionally looked like. You built a temporary corridor through it. You blinded or destroyed enough sensors. You attacked enough missile batteries. You disrupted enough communications. Then you pushed the bombers through the opening. The concept worked. But it came with a terrible price. It required large numbers of aircraft. It consumed enormous amounts of fuel. It demanded extensive planning, and every additional aircraft introduced another opportunity for something to go wrong. The entire operation depended on concentration. You had to bring enough force together at the right time, in the right place, and keep that force alive long enough to complete the mission. The B-21 represents a fundamentally different philosophy. Instead of assembling an enormous force to smash a hole through the defensive wall, the objective is to make the wall increasingly irrelevant. And that begins with stealth, but not the simplified version of stealth most people imagine. Stealth is not invisibility. A stealth aircraft does not disappear from physics. There is no magical switch that makes an aircraft invisible to every radar on Earth. Different radars operate at different frequencies. Different frequencies interact with an aircraft differently. Some radars are optimized for detecting objects at long distances. Others are optimized for producing extremely precise tracks, and that distinction matters enormously. A surveillance radar might provide an indication that something unusual is somewhere in a large region. But a missile system needs far more than a vague indication. It needs an accurate and continuously updated track. It needs to know where the target is, where it is going, how fast it is moving, and where the weapon needs to intercept it. That creates a critical gap between detection and engagement. And stealth is designed to exploit that gap. The aircraft's shape, materials, edges, surfaces, engine integration, and countless other design decisions are all intended to control how electromagnetic energy interacts with the aircraft. The goal is not necessarily to make every radar see absolutely nothing. The goal is to make the information a radar receives insufficient, inconsistent, or too difficult to turn into a reliable firing solution. That is a much more practical objective, and it changes everything. The flying wing advantage. Look at the basic silhouette of the B-21. There is no conventional vertical tail. There are no large external control surfaces sticking out into the airflow. The aircraft presents itself as a highly integrated flying wing design that is not an aesthetic decision. It is a signature management decision. Every exposed edge can interact with radar energy. Every abrupt geometric transition can create reflections. Every opening, seam, panel, intake, and external component has to be considered. The cleaner the overall geometry, the greater the opportunity to control those reflections. The B-2 demonstrated how powerful this philosophy could become decades ago. But the B-21 was designed in an entirely different technological environment. Engineers now have dramatically more computational power. They have far more sophisticated modeling. They can simulate aerodynamic behavior, electromagnetic signatures, thermal effects, structural loads, manufacturing processes, and countless other characteristics before committing to physical hardware. The aircraft can effectively exist inside a digital environment long before the final aircraft exists on a runway. That is one of the biggest differences between designing an aircraft today and designing one several decades ago. The computer is no longer merely helping engineers draw the airplane. It becomes part of the airplane's development process itself. And that matters because stealth is not one feature. It is the combination of thousands of decisions that must work together. The real problem for the defender. Now imagine the air defense commander again. His system receives a warning. Something may be present, but the track is uncertain. The information does not become precise enough. The missile battery cannot simply launch at a vague point in the sky and expect success. The defender needs certainty. The attacker only needs an opportunity. That difference is enormous. An air defense system must continually answer, where is the aircraft? A stealth aircraft is designed to make that question difficult. Then comes the second question. Where will it be several seconds from now? That is harder still. And then, can we guide a weapon to that future position? If the defender cannot maintain a sufficiently precise track, the entire chain begins to break. The missile may still exist. The radar may still be functioning. The command center may still be operating. The launcher may still be loaded. But none of those things matter if the network cannot produce the information required to use them effectively. This is the subtle distinction behind the idea that stealth can make air defenses useless. It does not necessarily mean the radar has been destroyed. It does not necessarily mean the missile has been jammed. It means the system can remain physically intact while becoming strategically ineffective against the target it was supposed to stop. That is a much more dangerous problem, because replacing a destroyed radar is straightforward compared with solving a problem that begins with the fundamental physics of detection. The B-21 does not have to enter alone, but stealth is only one side of the radar's value. There is another possibility that makes the aircraft even more difficult to defend against. The B-21 is not limited to one method of attack. It can be part of a larger strike architecture. That means a defender cannot assume that the bomber must physically penetrate every layer of the defensive network to reach its objective. A strike aircraft can potentially employ weapons from outside the most dangerous portion of the defended zone, and that creates a nightmare for the defender. Move defensive systems farther forward, and they become more exposed. Keep them deeper inside the country, and the attacker has more freedom to operate around the outer layers. Concentrate defenses around one critical area, and another region becomes vulnerable. Spread everything evenly, and the defensive network becomes thinner everywhere. This is the fundamental problem with defending against an adversary that can choose between penetration and standoff attack. The defender has to protect the entire board. The attacker only has to find the weakness, and that turns geography into mathematics. When defense becomes a numbers game, an air defense system is extremely powerful when it knows where to concentrate. It becomes much less efficient when it has to defend everything simultaneously. Imagine a country with hundreds of important military sites. Air bases, command centers, missile installations, naval facilities, radar stations, weapons storage areas, industrial infrastructure, leadership facilities. The defender cannot assume which one is going to be targeted. And that uncertainty creates a resource problem. Every radar has a finite field of view. Every missile battery has a finite engagement envelope. Every fighter has limited endurance. Every interceptor has limited ammunition. Every command network has finite capacity. If the attacker can remain uncertain enough, the defender is forced to spend enormous resources protecting possibilities rather than responding to confirmed threats. That is where the strategic effect becomes much larger than the aircraft itself. The B-21 does not need to destroy every radar. It needs to force the enemy to reconsider what those radars can actually guarantee. The aircraft that can change after it is built. There is another element of the radar that may prove just as important as its shape: software. Modern military aircraft are no longer static machines. The threat environment changes continuously. New sensors appear, new missile systems enter service, new electronic warfare techniques emerge, new frequencies are used, new tactics are developed. An aircraft designed around a fixed configuration can eventually become outdated. The B-21's architecture is intended to make upgrades far easier. The Air Force has emphasized an open systems approach, allowing hardware and software components to be upgraded without redesigning the entire aircraft every time the threat changes. That matters because the aircraft does not have to remain frozen in the form in which it first enters service. The defense evolves. The radar can evolve with it, and that creates a different kind of competition. For decades, the defender could study an aircraft and attempt to build a countermeasure, specifically designed against it. But what happens when the aircraft's sensors, electronic capabilities, software, and mission systems can be continuously modified? The target becomes harder to define, and a defense optimized against yesterday's configuration may not remain optimized against tomorrow's. The contest becomes less about one aircraft versus one missile. It becomes a race between adaptation cycles. Who can change faster? The B-21 as a networked weapon, and the radar was never intended to operate as an isolated machine. The future battlefield is becoming increasingly networked. Uncrewed aircraft can scout ahead. Other platforms can provide electronic effects. Sensors can be distributed across multiple systems. Weapons can be launched from different directions. Information can flow between aircraft, ships, satellites, ground stations, and other nodes. The bomber can therefore become more than a weapons carrier. It can become a central node in a much larger combat network. That possibility changes how the aircraft should be evaluated. The question is no longer simply, how many bombs can the B-21 carry? The more important question becomes, how much combat power can the B-21 connect together? And that is where the aircraft's future becomes especially interesting, because the Air Force has also discussed the possibility of increasingly autonomous operations. The exact form and timeline remain matters for future development, but the direction is clear. Reduce the dependence on putting humans directly inside the most dangerous environments. Increase the number of systems that can cooperate and make the overall force more distributed. That is not just an aircraft upgrade, it is a change in how air warfare is organized. Why the number matters. There is another critical difference between the B-21 and its predecessor. Quantity. The B-2 Spirit became one of the most iconic aircraft ever produced, but only 21 were built. That made the aircraft extraordinarily valuable. It also created a problem. When you possess only a few dozen strategic aircraft, every individual airframe becomes precious. Every accident matters. Every maintenance problem matters. Every deployment has to be carefully considered. A weapon that is too valuable to risk can become less useful precisely because of its value. The B-21 program is designed around a different philosophy. The Air Force has publicly planned for a fleet of at least 100 aircraft. That number matters enormously, because stealth becomes strategically different when it is no longer available only in tiny quantities. One aircraft is a capability. A fleet becomes a persistent problem for the adversary. A large fleet can rotate through maintenance. Aircraft can operate from multiple locations. Missions can be distributed. Losses, while still serious, do not threaten the existence of the entire capability. And most importantly, the defender can no longer assume that the stealth bomber is a rare visitor. It becomes part of the permanent strategic environment. What the B-2 taught America. To understand why this matters, look at the B-2. During Operation Allied Force in 1999, B-2 bombers demonstrated something extraordinary. They could launch from the continental United States, cross an ocean, strike heavily defended targets, and return without requiring the bomber itself to be based near the battlefield. It was an astonishing demonstration of range and stealth. But the aircraft came with another reality. The B-2 was incredibly expensive and complex. Only a small number were ever produced. That scarcity became part of the aircraft's strategic identity. You could send a B-2 into danger, but everyone understood how difficult it would be to replace one. The B-21 was designed with that lesson in mind. Smaller, 2 engines rather than 4. There's greater use of mature technologies, more emphasis on digital engineering, more attention to maintainability and production. The objective was not simply to build an aircraft that was technologically spectacular. It was to build one that could become a sustainable fleet. That distinction may ultimately prove more important than any individual performance specification. Because a revolutionary aircraft that cannot be fielded in meaningful numbers changes little. A highly capable aircraft that can be produced, maintained, upgraded, and deployed repeatedly can change an entire strategy. Building the aircraft before building the aircraft. One of the most important parts of the B-21 program happened before much of the public ever saw the aircraft. Digital engineering. Instead of relying entirely on physical prototypes and sequential testing, engineers could model the aircraft extensively in a virtual environment. A digital representation could be examined, modified, tested, and refined before the physical manufacturing process reached the same stage. That does not eliminate testing. It does not make real-world engineering unnecessary, but it can reduce uncertainty, and it can allow problems to be discovered earlier. That is particularly valuable for a stealth aircraft because so many characteristics are interconnected. Changing one surface can affect aerodynamics. Changing an intake can affect radar signature. Changing a material can affect weight or maintenance. Changing a component can affect manufacturing. The digital environment allows engineers to see those relationships much earlier. The result is not simply a more advanced bomber. It is a different way of building a bomber. The day the Raider appeared, then came the moment the public finally saw the aircraft. On December 2, 2022, Northrop Grumman rolled the first B-21 out at Palmdale, California. But even that reveal was carefully controlled. The public did not receive a complete view of the aircraft from every angle. Certain details remained obscured. That was hardly surprising. For a stealth aircraft, the rear of the machine, exhaust treatment, control surfaces, and other design elements can reveal enormous amounts of information. Then, on November 10, 2023, the B-21 made its first flight from Edwards Air Force Base. The aircraft had moved from computer models and engineering drawings into the real world, and that changed the conversation. The Raider was no longer simply a future concept, it was flying. Testing had begun, production was underway, and the long process of turning the design into an operational capability had started. The aircraft is expected to enter service at Ellsworth Air Force Base with additional bases planned. The goal is not to preserve one extraordinary prototype. The goal is to create a new bomber fleet that can remain relevant for decades. The strategic trap. Now imagine you are the commander responsible for defending against that fleet. Your first instinct is obvious. Find the bomber, build a radar that can detect it. Develop a missile that can engage it. Deploy more fighters, add more sensors, improve the network, but every solution has a cost. If you move your sensors closer to the expected penetration routes, they become more exposed. If you keep them far away, you may reduce the opportunity to detect and track the aircraft. If you spread missile batteries across every possible target, you dilute their concentration. If you concentrate them around the most important targets, other targets become more vulnerable. And if the bomber can launch weapons without entering the deepest part of the defended zone, even a perfect penetration strategy may not solve the entire problem. This is why the B-21 is more than a stealth aircraft. It creates a dilemma, and the strongest dilemmas are the ones where every response carries a cost. The weapon of uncertainty. Perhaps the most powerful capability of a stealth bomber is not what the enemy knows about it. It is what the enemy cannot know. Imagine waking up every morning knowing that an aircraft might already be operating somewhere inside your defended region. You cannot prove that it is there, but you also cannot prove that it is not. You cannot ignore the possibility, so you have to prepare for it. That means maintaining radar coverage, keeping aircraft ready, protecting command centers, moving or hardening sensitive assets, maintaining missile batteries, building redundancy, spending money, then doing it again tomorrow, and the day after that, and the day after that. This is deterrence through uncertainty. The bomber does not need to attack every night. It only needs to make the defender believe that an attack could happen. That possibility can impose costs long before a weapon is ever released. And this is where the B-21 becomes strategically different from a conventional strike aircraft. Its presence, or even the possibility of its presence, can influence enemy behavior. The nuclear dimension. The Raider also exists inside an even larger strategic framework. The B-21 is intended to form the airborne component of America's nuclear triad alongside land-based missiles and ballistic missile submarines. That gives the aircraft a role far beyond conventional strike. A bomber can be launched, it can remain airborne, it can change its route, it can be recalled, and its visible deployment can itself become a strategic message. That flexibility is fundamentally different from a weapon that has only one irreversible trajectory. In a crisis, uncertainty matters. A rival government does not simply have to calculate what America can destroy. It has to calculate what America might be preparing to do. And that calculation becomes more difficult when a platform can operate at long range, remain difficult to detect, and carry both conventional and nuclear weapons. what we still don't know. But there is an important reality check. Much of the most interesting information about the B-21 remains classified. The public does not know its precise radar cross-section. Its exact combat radius is not publicly established. Its complete payload details are not public. Its maximum speed is not the central public focus either. And nobody outside the cleared community can honestly claim to know exactly how the aircraft would perform against every specific radar and missile system on Earth. Online estimates are still estimates. Some are based on engineering assumptions. Others are based on comparisons with the B-2. Some are simply speculation. The honest position is therefore straightforward. The program is real. The aircraft is real, the testing is real, the production is real. But many of the numbers people confidently quote remain unknown, and that uncertainty is itself revealing. Because the aircraft's greatest secrets are precisely the details that would tell an adversary how best to defeat it. The billion-dollar clue. There is, however, another way to establish that the B-21 program is not merely an artist's rendering. There's money. In early 2024, Northrop Grumman disclosed a massive pre-tax charge associated with the initial B-21 production lots. The company had entered fixed price agreements. Then real-world production costs increased. Inflation changed the economics. Manufacturing proved more expensive than anticipated, and under the structure of those contracts, Northrop absorbed a substantial portion of that financial pain. It was an ugly number, but it also demonstrated something important. You do not incur enormous production losses on an aircraft that exists only inside a presentation. There were real aircraft. Real factories, real components, real production contracts, real engineering challenges. The B-21 had moved firmly beyond the conceptual stage. And the target unit cost, often discussed in the neighborhood of several $100 million, before certain accounting and program costs, is itself central to the strategy. The goal is not to make the world's cheapest bomber. The goal is to make a stealth bomber affordable enough to build in meaningful numbers. That is the difference. The future air war. Now return to that radar operator. The room is quiet. The screens are glowing. The antennas are turning. Nothing appears obviously wrong. The network has not collapsed. No missile battery has been destroyed. No command center has been bombed. And yet the defender may still be losing the engagement before the first weapon is fired. Because the entire system depends on one assumption, that the threat can be detected, tracked, identified, and engaged in time. If that chain breaks, the rest of the architecture becomes increasingly difficult to use. And the B-21 was designed around precisely that problem. Not to become physically invulnerable, not to become magical, not to defeat every defense under every circumstance, but to reduce the defender's confidence in the information he needs to make those defenses work. That is a much more subtle form of power, from destroying defenses to bypassing them. For much of the history of air warfare, the basic philosophy was straightforward. If the enemy built a wall, destroy the wall. If he built more radars, jam them. If he built more missiles, overwhelm them. If he built stronger defenses, bring more aircraft. The B-21 represents another possibility. What if you don't need to destroy the wall? What if you can move through the environment in a way that makes the wall far less useful? That is the deeper promise of stealth. And the Raider takes that philosophy and combines it with long-range weapons, digital engineering, open architecture, networked warfare, potential autonomous capabilities, and a production strategy intended to create a large fleet. Each component matters, but the combination is what makes the concept powerful. A stealth bomber that is difficult to detect is dangerous. A stealth bomber that can launch weapons from outside defended areas is more dangerous. A stealth bomber that can operate as part of a larger network is more dangerous still. And a fleet of such aircraft that can continuously receive new software, sensors, and capabilities become something very different from the strategic bombers of previous generations. The real threat isn't the bomber. The most important thing about the B-21 may therefore be something that cannot be measured by its wingspan or payload. It is the uncertainty it creates. An adversary cannot simply look at a radar screen and know that the absence of a track means the absence of a bomber. That is the nightmare, because once the defender loses confidence in what the sensors are telling him, every decision becomes more expensive. Should he move the missiles? Should he launch fighters? Should he keep aircraft airborne? Should he protect one base or another? Should he assume the bomber is approaching from the north or the south? Should he defend the target or the route or both? The attacker gets to choose. The defender has to cover the possibilities. And that asymmetry is where the strategic advantage begins. Here's the final question. For 70 years, the contest between aircraft and air defense followed a familiar pattern. One side improved its radar, the other improved its aircraft. The defender developed better missiles. The attacker developed better electronic warfare. The defender extended its detection range. The attacker improved its stealth. Every move created another countermove. But the basic question remained the same. How do you get through? The B-21 offers a different answer. Don't necessarily fight the defense on its terms. Don't necessarily destroy every sensor. Don't necessarily overwhelm every missile battery. Instead, make the defender struggle to obtain the information required to use those systems effectively. Make the threat difficult to locate. Make it difficult to track. Make its future behavior harder to predict. Give it weapons that can be employed from multiple ranges, connected to other platforms. Allow its systems to evolve. And build enough of them that the enemy cannot simply wait for the handful of aircraft to appear. That is why the B-21 Raider matters. It is not simply another bomber. It represents a shift from breaking through defenses toward making the defensive architecture itself less certain of what it is fighting. And that distinction could shape American long-range air power for decades. Because the most dangerous aircraft is not necessarily the one that destroys the most targets. Sometimes it is the aircraft that forces the enemy to spend billions preparing for a threat he can never reliably see coming. And somewhere on some future night, another radar operator may once again stare at an apparently empty sky. The screens will be functioning, the antennas will be turning, the missiles will be ready. The command network will be waiting. Everything will appear normal. But somewhere beyond the reach of certainty, an aircraft may already be moving toward its objective. And the defender's greatest problem will not be that his system stopped working. It will be that the system is working exactly as designed, against a threat it cannot reliably see. If you found this deep dive valuable, make sure to like the video and subscribe for more stories about America's most advanced military technology. Because the future of air warfare may not belong to the side with the biggest radar. It may belong to the side that can make the radar ask the wrong question.